Hello, everyone. Today I'm going to talk about task-based parallelism in OpenMP and how we can write such a program using OpenMP. So first, let's define what a task is. Basically, tasks are independent units of work, and each of them is composed of a piece of code that you want to execute and some data that you want that specific task to work with to perform some computations, for example. We can define tasks and execute them in serial or in parallel. So for example, here in the right figure, we have three independent tasks, task A, B, and C. And here we are running them in serial. So which means that we first execute task A, we wait until it finishes the computation and the execution. Then we execute task B, and finally we execute task C. So the point here is if these tasks are independent, we can also run them in parallel. And let's see how we can do that. To do these executions in parallel, we can assign each task to a thread. And that thread might execute the task immediately, or it can defer the execution for later time. So as you can see here in the right diagram, we now are executing these three tasks in parallel. So task A is executed by thread A, task B by thread B, and task C by thread C. And the threads can execute these tasks in any time, but mostly concurrently. The main pattern that we use to write task-based program is to let a thread to create the tasks while the other threads execute the task, and then they can have also coordination. So let's see how exactly we can write a simple task-based program in OpenMP. Before seeing the actual code, it is important to see what this single construct does in OpenMP. So basically, the single construct is a directive in OpenMP that allows only one thread to execute the code that is within this single construct. So for example, here in the right, we created a pool of threads using this pragma OMP parallel. So here, this do many things function is executed by different threads. Depends on how many threads OpenMP has created for us. And then when they reach this pragma OMP single, only one thread can enter this code snippet and can enter that code region and execute this exchange boundaries function, for example. And here, after this execution is done, other threads should wait for this single thread to finish the execution, and then together they can continue execution, which means that we have an implicit barrier at the end of this single block, right? So here the do many things function and do many other things function are executed by all threads, but only one thread would be responsible to execute this exchange boundaries function because of this pragma OMP single, right? So we can use this pragma OMP single construct to assign a thread to create different tasks for us. So let's see how we can do that in this slide. So for creating a task using the thread that I was talking about, we can use this pragma OMP task directive in OpenMP, which defines a task that can be executed asynchronously by any thread in the thread team that has been created by the OpenMP, right? So in this case, instead of running the code immediately, this OMP task directive creates a task and it adds this task into something called task queue. And then the threads will pull one of these tasks from this task queue, and then they execute them asynchronously or in parallel if they are free. So for example, in this code snippet in the right, we first create a pool of threads using this pragma OMP parallel. So here we do that. And then using this pragma OMP single, we let only one thread to enter this region, right? And by this pragma OMP task, that thread that is entered this region will create a task for each of these functions, Fred, Daisy, and Billy, and add these tasks into a task queue, right? And finally, after we reach the end of this single construct, OpenMP makes sure that all of these tasks are executed by different threads, right? But this is not always the case. Probably at some point you want Fred and Daisy to be executed first, and then you want for Billy task to be executed. Then you can have more control using this pragma OMP task wait directive. So if you put it here, then OpenMP makes sure that the Fred and Daisy functions are executed in parallel first, and then you can wait for Billy to start execution, right? So this is basically uh, the basics actually of how you can write task-based programs using OpenMP, which is quite simple and intuitive. The thing is, you should be able to decompose your problem into different tasks that are independent, and then you can use this pragma OMP single and pragma OMP task to create and execute them in parallel. As I mentioned, this was only a basic introduction to task-based parallelism, and for more information, you can use these references that I provided here. So I hope this video was useful for you, and have a good time.